Hello, friends. Let's solve this apparently challenging question, right? But it is not challenging actually if you observe it carefully. What you see here is the two brackets are squared, and each of the bracket is having the same fraction. For example, 411 over 15 is same as here and here. And then we have 15 over 71, 15 over 71 here. Okay, so what can we do here to begin with this? Can we replace this fraction by A, this by B? Same here for this bracket, A and B, right? So let's rewrite this fraction by using A and B, and we get here A plus B bracket square minus A minus B bracket square. Now what do you observe? Do you see that? This is nothing but one of the identity. This also is nothing but identity, right? So let's expand each of the bracket. Okay, let's do it on the side here. So we have here A plus B bracket square. This can be written as A plus B times A plus B. Okay, let's expand this bracket. By first starting with A, multiply the first term of the first bracket to each term of the second bracket. So A times A square. So A times A is A square. Then A times B gives us plus AB, right? Then take the second term of the first bracket, then to multiply each term of the second bracket. So B times A gives us, B times A is nothing but A times B, so we can write it as plus AB, and then B times B gives us plus B square, right? So finally we have here is it A square plus 2AB plus B square. So we have expanded this bracket to get this. So let's copy it down here. We can write this as, right, this becomes A squared plus 2AB plus B squared, right? This part. Now let's expand the second bracket, which is this, okay? So now let's write it A minus B bracket squared, which is nothing but A minus B times A minus B. Multiply similarly here by multiplying first term of the first bracket to each of the term of the second bracket. So we get here A squared minus, first this is A squared, and then A times minus B, which gives us minus AB. Now take the second term, which is negative B, and multiply to each term. That gives us minus B times A, which is nothing but minus AB, and then minus B times minus B gives us plus B squared. So we have here A squared, these together becomes minus 2AB plus B squared, right? So we have expanded this to this. So let's write down this part here. Minus of A squared minus 2AB plus B squared, right? Okay. Now let's see how to solve it further. We can just copy down this part as it is because it is only positive, right? So let's copy it down here. So A squared plus 2AB plus B squared. As they're all terms of positive, there is no change in there. But in the second bracket, in this bracket, what's happening is there is a negative sign outside. So whenever you're multiplying by a negative sign to the terms inside the bracket, each term inside the bracket is going to change its sign. So what is going to happen here is, yeah, so minus times A square gives us minus A square. Then this minus times minus 2AB gives us plus 2AB. And then this minus times B square gives us minus B square. Do you get this? Yes. Now, what do we do further? Now you see that this A square is positive and this is negative, so they get cancelled. Similarly, this B square and minus B square is getting cancelled. And what you're left with is 2AB plus 2AB, which gives us 4AB. Right? So what we did here, we simplified this bracket to only 4AB by using the identities, right? Yay! Now, what we are going to do is we are going to replace a and b by the original fraction. So 4 times a, the original fraction a is nothing but this. So let's write 411 over 15 times your b is this fraction. So it's 15 over 71, right? And now you see that the middle fraction here is nothing but mixed fractions. Let's convert this into the improper one first. How do we do that? 411 over 15. We multiply these two. 15 times 4 is 60. 60, and then let's add these, right? 60 plus 11 gives us 71. So it becomes 71 over 15, right? So let's rewrite this again, which becomes 4 times 71 over 15 times 15 over 71. Now, do you observe here that these two fractions are reciprocal of each other? So we can cancel them further. 15 gone, 71 gone, and what are you left with is only 4. And that's the answer for this fraction, isn't it? And again, we did it. I hope you enjoyed this question. Thank you so much.